Hello everyone, in this video we'll learn a program to create a linked list of n nodes and insert a new node at the middle of a linked list at nth position. Linked list is a linear data structure. It consists of items called nodes which contain two parts. The first part stores the actual data and the second part has a pointer that points to the next node. First node in the linked list is called head, while the last node in the linked list is called tail. As we see, the last node of the linked list will have its next pointer as null, since it will have any memory address pointed to. Each node has a pointer to the next node, and the data items in the linked list need not be stored at contiguous location. The nodes can be scattered in the memory. We can access the nodes anytime as each node will have an address of the next node. There are three steps to insert new node at any position in a linked list. First of all, we have to create a new node. Then after that, traverse to the n-1th position of the linked list and connect the new node with the n+1 nodes. That means the new node should also point to the same node that the n-1th node is pointing to. Now if we want to insert a node between 20 and 40, the new node next pointer field now point to the 40. We can say new node next pointer field is equal to temp arrow operator next, where temp is the n-1th node. Now at last connect the n-1 node with the new node, that is n-1th node will now points to the new node, that is temp to next is equal to new node, where temp is the n-1th node. After insertion, the next pointer field of 20 now points to 30 and next pointer field of 30 now points to 40. Let's see the program to insert a node at the middle of a linked list. Then how to create a linked list. The first step of creating linked list of n nodes starts from defining node structure. Every node having two parts. The first part is known as data part and the second part is known as address part. We need a custom type to store our data and location of next link node. This is our node structure. Struct node. Struct is a keyword. Node is the name of the structure. Structure having two members, data and next, where data is the data you want to store in the list and star next is a pointer to the same structure type. Node is the structure, name, and struct is a keyword. The star next will store location of next node if exist, otherwise null. The node structure may vary based on our requirement. You can also have user defined types as node data section. Then declare a pointer to node type variable to store link of first node of the linked list. You can also declare variable of node type along with node structure definition. There are two ways to define the structure variable: inside structure definition and outside structure definition. Now in this case, structure variable defined inside the structure definition. After that, declare two functions. First function is for create a linked list and second function is for traverse a linked list. Void is a return type, create list is the name of the function, and function having one argument, that is n. N denotes total number of nodes in a linked list. In second function, void is a return type and traverse list is the name of the function. Then inside the main function, declare a variable n. N is for total number of nodes in a linked list. Then input number of nodes to create from user, store it in a variable that is n. After that, call a create list function. When this function call, control transfer to the definition of create list function. With the help of create list function, we can create a list of n nodes. Void is a return type, create list is the name of the function, and int n. N is the parameter. Inside the function definition, declare two more helper variables of node type, that is struct node star new node comma star temp. Star new node and star temp are two helper variables of node type. If the value of n is greater than 0, then create our first node, that is head node. We use dynamic memory allocation to allocate memory for a node, that is head is equal to struct node star malloc function, then size of struct node. With the help of malloc function, we can dynamically allocate memory. If there is no memory to allocate for a head node, if head is equal to null, then print some error message and terminate the program. Otherwise, move to the next step. Then input data from user and assign to head using head arrow operator. Data is equal to data. At first, head node points to null, that is head arrow operator next is equal to null. Now we are done with head node. Then we should move to creation of other nodes. Copy reference of head to some other temporary variable, that is temp. Temp is equal to head. Now we will use temp to store reference of previous node. Then create n-1 nodes and add to the list. Apply a for loop for I is equal to 2, I is less than equal to n. And I++ inside the definition of for loop, allocate memory and assign memory reference to a new node with the help of malloc function. If memory got allocated successfully, then read data from the user and assign to data section of new node. That is new node arrow operator, data is equal to data, and make sure that new node points to null. Now link previous node with newly created node, that is temp arrow operator next is equal to new node. Then make current node as previous node using temp is equal to temp arrow operator next. Then I++. Again repeat all the steps, and after that call the traverse list function. When this function call, control transfer to the definition of traverse list function. Inside the definition of traverse list function, create a temporary variable for traversing and return if list is empty. If head is equal to null, then cout list is empty. Otherwise, assign reference of head node to a temp variable. Temp is equal to head. Then repeat below steps till temp not equal to null. And inside the definition of while loop, temp arrow operator data contain the current node data. You can print it or can perform some calculation on it. Once done, move to the next node using temp is equal to temp arrow operator next. Then again go to step 97. Again check the while condition. Temp is not equal to null. Then temp arrow operator data contain the current node data. Once done, move to the next node using temp is equal to temp arrow operator next. After that, declare a function to insert a node at the middle of a linked list. Void is a return type. Insert node at middle is the name of the function. And this function takes two arguments, data and position. Data is a item that we have to insert at the middle of a linked list, and position is a location. And inside the main function, first of all we have to input the data. Then after that input the position to insert a new node. Then call the function insert node at middle, and this function takes two arguments, data and position. When this function call, control transfer to the definition of insert node at middle function. Void is a return type. Insert node at middle is the name of the function, and this function takes two arguments, data and position. Data is the element and position is the location. And inside the definition of insert node at middle function, first of all declare two helper variables of node type, that is new node and temp. Then use dynamic memory allocation to allocate memory for a new node. If there is no memory to allocate for a new node, that is, if new node is equal to null, then print some error message and terminate. Otherwise, move to the next step. Input data from the user and assign to a new node. That is, new node to data is equal to data. At first, new node points to null. New node to next is equal to null. Now we are done with the new node. Then we should move to creation of other node. Then copy the reference of head to a temp variable. And after that, traverse to the linked list n-1 position, and with the help of for loop, traverse the list. After that, check the if condition. If temp is not equal to null, if this condition is true, then link address part of a new node, that is, new node to next is equal to temp of next, and then link address part of n-1 node, that is, temp to next is equal to new node. Then with cout, print the message data inserted successfully. And if this condition is evaluated to be false, then we are unable to insert data at a given position. We can say invalid location is there. Now run this code. After the execution of this code, first of all enter the total number of nodes. Total number of nodes are 4. Enter data of first node. Enter data of second node. Enter data of third node. And enter data of fourth node. Then data in the linked list is 12, 13, 14 and 15. Then enter data to insert at middle of a list. Data is 35. Then enter the position to insert a new node. We have to insert a node at third position. Then after insertion, data in the linked list is 12, 13, 35, 14 and 50. 35 is inserted at third location. This is all about to insert a node at the middle of a linked list.